Hello friends, today I am going to discuss MCQs for basic electric and electronics. It is very important for Nepal Engineering Council license exam for electronics and communication. Question number 1. The superposition theorem is used to option A. Calculate total impedance, option B. Determine the current and voltage in a linear circuit with multiple sources, option C. Find the power in AC circuits, option D. Convert star networks to delta networks. The right one is option B. Determine the current and voltage in a linear circuit with multiple sources. Question number 2. The superposition theorem can be applied to option A. Non-linear circuits, option B. Linear circuits only, option C. Both linear and non-linear circuits, option D. AC circuits only. The right one is option B. Linear circuits only. Question number 3. When using the superposition theorem, how are the sources treated? Option A. All sources are left active. Option B. Only one source is considered at a time, others are replaced by their internal resistance. Option C. All sources are considered simultaneously. Option D. None of the above. The right one is option B. Only one source is considered at a time, others are replaced by their internal resistance. Question number 4. In a circuit with two voltage sources and one current source, how many circuits must be solved using the superposition theorem? Option A 1, option B 2, option C 3, option D 4. The right one is option number C 3. Question number 5. The superposition theorem is particularly useful for analyzing circuits with option A. One source, option B. Non-linear elements, option C. Multiple sources, option D. Single resistors. The right one is multiple sources. Question number 6. Thevenin's theorem simplifies a complex linear circuit into a single. Option A. Voltage source and series resistance, option B. Current source and parallel resistance, option D. Resistor network, and option D. Capacitor network. The right one is option A. Voltage source and series resistance. Question number 7. The equivalent voltage source in Thevenin's theorem is known as option A. Thevenin current, option B. Thevenin voltage, option C. Norton current, option D. Norton voltage. The right one is Thevenin voltage. Question number 8. In Thevenin's theorem, the equivalent resistance is found by option A. Measuring the resistance directly, option B. Replacing all voltage sources with short circuits and current sources with open circuits, option C. Measuring the voltage directly, option D. Using the power formula. The right one is option B. Replacing all voltage sources with short circuits and current sources with open circuits. Question number 9. Thevenin's equivalent circuit is useful for option A. AC circuits only, option B. DC circuits only, option C. Both AC and DC circuits, option D. Power circuits only. The right one is option C. Both AC and DC circuits. Question number 10. When finding the Thevenin's equivalent voltage, you need to option A. Short all voltage sources, option B. Open all current sources, option C. Calculate the open circuit voltage across the terminals, option D. Measure the current directly. The right one is option C. Calculate the open circuit voltage across the terminals. Question number 11. Norton's theorem states that any two-terminal linear network can be replaced by an equivalent option A. Voltage source in series with a resistor, option B. Current source in parallel with a resistor, option C. Resistor network, option D. Capacitor network. The right one is option B. Current source in parallel with a resistor. Question number 12. The current source in Norton's equivalent circuit is known as option A. Norton voltage, option B. Norton current, option C. Thevenin voltage, option D. Thevenin current. The right one is option B. Norton current. Question number 13. Norton's equivalent resistance is found by option A. sorting all voltage sources and opening all current sources. Option B, opening all voltage sources and sorting all current sources. Option C, using a voltmeter. Option D, using an ammeter. The right one is option A, sorting all voltage sources and opening all current sources. Question number 14. Norton's theorem is applicable to. Option A, linear networks only. Option B, non-linear networks only. Option C, both linear and non-linear networks. Option D, none of the above. The right one is option A, linear networks only. Question number 15. Thevenin's and Norton's theorems are related because. Option A, they are derived from different principles. Option B, Norton's theorem is a dual of Thevenin's theorem. Option C, they can't be used interchangeably. Option D, they are unrelated. The right one is option B, Norton's theorem is a dual of Thevenin's theorem. Question number 16. The maximum power transfer theorem states that the maximum power is transferred when the load resistance is. Option A, equal to the source resistance. Option B, twice the source resistance. Option D, half the source resistance. Option D, 0. The right answer is equal to the source resistance. Question number 17. In AC circuits, maximum power transfer occurs when the load impedance is. Option A, equal to the source impedance. Option B, half the power impedance. Option C, twice the source impedance. Option D, complex conjugate of the source impedance. The right one is option number D, complex conjugate of the source impedance. Question number 18. The maximum power transfer theorem is used to. Option A, minimize power loss. Option B, maximize power delivery to the load. Option D, determine the total resistance in a circuit. Option D, calculate voltage drop in a circuit. The right one is option B, maximize power delivery to the load. Question number 19. The maximum power transfer theorem is applicable to. Option A, DC circuits only. Option B, AC circuits only. Option C, both AC and DC circuits. Option D, high frequency circuits only. The right one is option C, both AC and DC circuits. For maximum power transfer, the load impedance should match. Option A, the series impedance of the source. Option B, the parallel impedance of the source. Option C, the total impedance of the source circuit. Option D, the complex conjugate of the source impedance in AC circuits. The right one is option D, the complex conjugate of the source impedance in AC circuits. Question number 21. In a RL circuit, the phase difference between the voltage and current is. Option A is 0, option B 45 degree, option C 90 degree, option D 180 degree. The right one is option C, 90 degrees. Question number 22. In an RC circuit, the voltage across the capacitor lags the current by. Option A 0 degree, option B 45 degree, option C 90 degree, option D 180 degree. The right answer is option C, 90 degree. In an RLC series circuit at resonance, the impedance is option A, equal to the resistance, option B, minimum, option C, maximum, option D, infinite. Answer, the right one is option number A, equal to the resistance. Question number 24. The time constant of an RL circuit is given by. Option A, R by L, option B, L by R, option C, 1 by IL, option D, R by L square. The right one is option number B, L by R. Question number 25. In an RC circuit, the capacitive reactance is given by. Option A, 1 by 2 pi FC, option B, 2 pi FC, option C, R by C, option D, RC. The right one is option A, 1 by 2 pi FC.